Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we'll work another example with the critical value approach, and this time we'll try to do a one-tail test. The question being answered is, does education increase wages? So let's assume these are some of the data. We have beta hat being 1.9, the standard error 1, and let's say that we have a sample size of 25. So by saying that education increases wages, I'm kind of hinting that I actually want to know whether the beta is positive in this case. Okay, so I'm not interested in the negative effects. I only am interested in the effect being positive and being large enough, meaning different from 0. So direction in this case is quite important. This is going to dictate how we write our null and alternative hypothesis for the first step. The null hypothesis, nothing changes as usual, our beta is equal to 0. However, our alternative hypothesis now is beta being bigger than 0 because we're only interested in the positive direction. Now, what that also dictates for us right off the bat is that we are going to do a one-tailed test based on these alternative hypotheses, okay? Based on the information, let's, as usual, have the computation of the t-statistic. Our t-star is going to be, as usual, beta hat minus 0 divided by the standard error of the beta hat, which in this case is just 1.9 divided by 1.9. Okay, so we are 1.9 standard deviations above 0. But we need to know the distribution for these t-statistics so that we know where to look up in the table. Okay, so we have this t-statistic under the null hypothesis, meaning under all the Gauss-Markov assumptions being fulfilled. It follows a t-distribution of n minus 2, assuming, again, this is a simple regression. So just 23 degrees of freedom. Okay. Step 4, finding our critical value. So we need to know 3 important elements. We already know we have a one-tailed test. We already know that our degrees of freedom are 23. So it means we already know which row to look into. Now, for the column, I didn't really specify at the beginning of this exercise whether we were going to do this at the 5%, at the 10%, or the 1%. So let's just arbitrarily go ahead. In the previous exercise, we used 5%, so let's use 5% again here. So significance level 5%. Based on this information, we now need to look up the t-value for this case. And the t-critical for 5% and 23 degrees of freedom is a number that is approximately 1.71. So let's go and take a decision based on a graph and the rules that we know. So this is where the 0 is. Now, this is a one-tail test, which means that once I have my t-critical, so my t-critical is right here, being 1.71. My rejection area is anything that is beyond that, so this is where I reject the null hypothesis. And keep in mind, this entire tail in here, this entire thing is 5%. Okay, so anything beyond that, I know I will reject it. Now, if I look up, I found that my t-star is actually 1.9. Okay, so 1.9, let's say it's right here. Very clearly, I can see that it's in the rejection area. So even if I wrote my absolute value t star is actually bigger than my t critical, which means that I will reject the null hypothesis. Okay? And interpretation, what does that mean for us? It means that the estimate is sufficiently large to be inconsistent with a non-positive value, okay? Which means that, yes, we have found like a statistically significant positive effect, okay? So what changed between the two-tailed case and the one-tailed case that we have in this exercise? Nothing much changed, okay? Apart from the alternative, the way that we write it, the tail structure in the graph in here, and the critical value on how we find it, okay? The information on the estimate, standard error, and how we use them to compute the t-statistic, nothing has changed in there. The t-critical, nothing has changed in there, okay? It's just that with the one-tail test, we are now concentrating all the probability in one direction instead of like splitting it into bits of 2.5, okay? Thanks for following this example. There will be one more example in which we will run a t-test, or a hypothesis testing based on a p-value approach, so that you can see more clearly how that logic translates into probability as well. So stay tuned, and I'll see you in the next video.